Good evening, students. In this session, we are going to continue solving Ncert exercises. This time it is a 4.3 Determinants chapter pertaining to area of triangle with three vertices. I have given you what are the vertices: x1, y1, x2, y2, x3, y3. Then the area is given as 1 by 2 of the determinant. Okay, it's a two-dimension triangle. x1, y1, x2, y2, x3, y3. So we need to write the column 3, fill it with ones. This is exactly the same formula which students learnt in class 10, half of x1 times of y2 minus y3 and so on. Okay, so this is the determinant way of writing it. And students must understand, in case the determinant value turns out to be negative, you have to present the modulus, absolute value, because area is always a positive quantity. Area is a positive quantity. And one more thing, the same procedure we can follow just like you used to do in class 10 to prove the three given points are collinear. In case the three given points are collinear, what you used to do in class 10, prove that area of triangle is 0. So the same thing we will do here. So the model of questions, they may ask you to find simply area of triangle given three vertices, or they can ask you to prove the 3 points are collinear, or the same procedure you can use to find the equation of line joining 2 points also. If, for example, one row alone you can alter. Okay, for finding equation of a line joining 2 points. So if you assume the 2 points are x1, y1 and x2, y2. So we already have learnt a formula in the straight lines chapter. So here the procedure will be, first row is xy, second row x1, y1, third row x2, y2. Third column as usual filled with ones, and RHS is 0 because the concept is xy, x1, y1, x2, y2. All of them lie on the same line, hence collinear. Because they are collinear, area of triangle happens to be 0. So that will land you on equation of line joining x1, y1 and x2, y2. Fine. So let us start evaluating the problem from Ncert. First, let us find area of triangle. Given vertices, let us take it in order. I am just choosing a question from exercise 4.3. One vertex 2, 7. Second is 1, 1, 10, 8. So that is one of the questions. So apply it in the same formula: x1, y1, x2, y2, x3, y3, column 3 filled with ones. And you can follow any method of evaluating the determinant. Nothing is prescribed or fixed. So as a customary procedure, let me choose row 1. So the A11 element is 2. Corresponding cofactor will be obtained by ignoring column 1, row 1. So which is 1, 1, 8, 1. So it is 1 minus of 8. 1 minus of 8. Followed by the next cofactor is made of negative sign. Element A11 is 7. What is the corresponding minor? So the method is ignore column 2. So you get 1, 1, 10, 1. So the product is 1 minus of 10. Followed by the next A13 element 1. Followed by the cofactor is 8 minus 10. So it is half. It is 1 minus 8 is minus 7 multiplied by 2. This is minus 9. Minus 9 multiplies minus 7, so positive 63. 8 minus 10 multiplies 1, negative 2. So the answer is half of 63 minus of 16, which means it is 47 by 2. Students always end the question with 47 by 2, the number as well as square units for area. So it's a simple procedure, the usual method. We are expanding by row 1. So row 1 we have used A11, A12, A13. Cofactors capital A11, capital A12, capital A13. The sign convention is positive, negative, positive. Minors are 1 minus 8, 1 minus 10, 8 minus 10. So it's as simple as that. 63 minus 16 gives 47 by 2. Is that okay? So we will take up one similar question for discussion. To continue, show that the next question will be, show that given here the vertex, there is a point A with coordinates A comma B plus C. There is a point B given coordinates B comma C plus A. There is a point C given coordinates C comma A plus B, and you have to show they are collinear. So at the beginning of this session, I already told you can use the same procedure to show 3 points are collinear by showing that the triangle area is 0. If the triangle area is 0, then half need not appear because triangle area is 0. Okay, so double the area also 0. So what happens? So we just evaluate. So you can say consider the determinant made of x1, y1, x2, y2, x3, y3. Third column to be filled with ones. We are just going to evaluate it. How to evaluate? It's a easy procedure. Column 1 is operated with C1 plus C2. So add C1 and C2, store the result in column 1. So the answer we get A plus B plus C, B plus C plus A, C plus A plus B. Column 2, B plus C, C plus A plus B. Okay. And all elements in column 1 you can see they are identical, A plus B plus C. This is a different order of A plus B plus C, different order of A plus B plus C. So you can take out A plus B plus C can be pulled out common factor from column 1. Then the column 1 becomes 1, 1, 1. The column 2, no change. Column 3, no change. But now you know the answer is 0. because C1 and C3 are both identical. Two columns are identical, makes the determinant value 0. So this is the way you prove the 3 points are collinear. So I request the students to just make note. We will continue in the same video. One more question. Let us continue. I am taking up the next question. Find the equation of line find the equation of line joining 1, 2 and 3, 6, okay, using determinants. That wording is there in the question, using determinants, okay, because this is going to be a examination, board examination in 12th standard. So students definitely cannot use the old ways of class 11, okay. So we can directly go for equation of line. So we know how to use this concept. You take together with xy, taken that as one of the points, 1, 2, 3, 6, okay, and concept is collinearity of these 3 points. Along with 1, 2, 3, 6, you take the general point, any point on the line x, y, which is collinear with these 2 points, and expand it as usual with row 1. So that makes x into 2 minus of 6 minus y into 1 minus 3 plus 1 into 6 minus 6 is 0. So we get negative 4x minus of minus 2y is 0, or I can change sign and divide by 2. So you get 2x minus y is equal to 0, or y equal to 2x. So 2x minus y equal to 0 is the equation of the line joining these 2 points. Let us continue. One more model of this exercise. If the area of triangle is 4 square units, find K. If vertices are K, 0, 4, 0, 0, 2. So let us see how you can solve this kind of question. Area is given. One of the coordinates is missing, given as K. You need to find the suitable value of K. So we know the formula for area: half of x1, y1, x2, y2, x3, y3, third column all 1, and the answer for the area is already known, 4. Let us expand. Half k times of 0 minus 2 only. The second element of row 1 is 0. Technically it is negative, and A13 is 1 into 8 is 4. We need to remember the concept that we got minus 2k plus 8. Minus 2k plus 8. Well, the k minus 2k may be either a positive value or a negative value. So the absolute value of the area is 4. So the area can be either plus 4 or minus 4. Okay. So let us do this. Negative 2k plus 8 happens to be plus or minus 8. 8 minus of 2k is plus or minus 8. So 2k is 8 minus or plus 8. So 2k is either 0 or 16, which means k is either 0 or 8. So please understand how this is evaluated. When we say area is 4, the evaluated determinant 8 minus 2k can either be positive or negative. It's the absolute value which is 8. So 8 minus 2k can be plus or minus of 8. So 2k can be either 0 or 16, giving answer for k as 0 or 8. Okay. So these are the models: finding directly area of triangle, proving collinearity, finding equation of line, and finding unknown coordinate k. Thank you, students. So in the next video, I will meet you with the procedure for finding inverse of matrix using the concept of determinant. Thank you.